Of course you're skeptical when you hear that somebody has written a natural history of the origins of speech. What leaves less trace than speech? We cannot know what was said just before we walked into a room, let alone what somebody said 20,000 years ago, or 200,000 years ago, or 2 million years ago. So how can anyone claim to tell the story of how humans began to talk? Surprisingly, however, there is a great deal of circumstantial evidence from many sources. Fossils, genetics, comparative biology, archaeology, neurology, anthropology, geology, and child development all have facts to contribute to the story. When combined, they support a surprisingly coherent narrative. For instance, we used to think the only comparative biology that mattered concerned apes. But now we find a whole new field of study. Songbirds once seemed too distant to have anything to contribute to this discussion. But it turns out they learned to sing their species' songs using the same brain functions that human infants use to learn how to speak their parents' language. Birds and people also show surprising similarities in the genetic changes needed to support learned vocalizations. So evidence from birds has something to tell us about a part of our language origins. Fossils are the most familiar sort of evidence, and over the past 50 years, scientists have put together an elementary account of human origins. We split off from the chimpanzee lineage about 6 million years ago, and we became upright walkers. 3.5 million years ago, there were a variety of bipedal apes spread across eastern and southern Africa. The fossil evidence also shows that starting about 2.75 million years ago, the Homo brain began to get bigger. This process of brain growth persisted until 200,000 years ago, when Homo sapiens appeared. Meanwhile, archaeological evidence has identified stone tools throughout East Africa's Great Rift Valley, and Central Asia too. The most basic kind of tool is called Oldowan, named after the Olduvai Gorge in Tanzania, where it was first identified. Crossing archaeological evidence of Oldowan tools with fossil evidence, we find an interesting coincidence. The tools appear at just the time the fossil brain starts getting bigger. Something was happening, but what? Comparative biologists have done extensive studies of the cost and benefit of brain sizes in a variety of species. My book, Babel's Dawn, examines the evidence in detail. Here I will make a long story short. Ape brains were already at about maximum size to support a competitive existence. But brains can break through this so-called gray ceiling when species start to cooperate. At that point, we can see brain growth take off. So it turns out we have decent evidence that cooperation began just as the Homo genus appears in the fossil evidence, and just as Oldowan tools came on the scene. Well, why would we start cooperating? Geology provides a clue. Fossil pollen and dust strata indicate that after a long cooling and drying out, the open savanna had finally appeared. Comparative biology jumps back into the story. We know from experiments that chimpanzees are smart enough to use a few words in sign language, and even to combine them into phrases. The problem is they are not cooperative, and they have no motive to share knowledge. Thus we know that as soon as the human lineage began to cooperate, it was already smart enough to use a few words and phrases. That does not prove we began to speak, but is strong circumstantial evidence that words are around 2 million years old. Of course, there's more to language than words and phrases. Grammar is just as important. There's also the ability to use metaphors and to tell mythological stories. Other forms of evidence are available to fill in some of those gaps, and where they are not, I'm ready to confess as much. The trickiest part of the story has been assembling the data from so many fields of inquiry. Experts specialize in their fields, but there are so many areas providing evidence that the story has to be synthesized out of the data that includes louse DNA, ape behavior, bird nesting, fossil stone tools, and on and on. I've spent the past 5 years assembling the data from whatever source I could find, and my book, Babel's Dawn: A Natural History of the Origin of Speech, spells out what we know, what we can guess, and what we can still only wonder about.